Hello, everyone. I have my son on the other side and me over here.
Hi, guys.
And just want to do a quick recap of yesterday. It was the black hole week. And essentially I said three things. There's no definition to this day. We don't know what a black hole is. We don't know how many dimensions it has. And regarding the definition, we don't know whether it's an object or a concept. That's basically the problem with the definition. Then we don't know how many dimensions it has. And there's a third one. Third one is what? Well, one of them is that nobody's verified, nobody's ever seen a black hole. So there's probably more than three here. Nobody has any idea how many dimensions. Nobody knows what it means. And there's one more. What am I missing? Helper. My mind went blank. Whoa, what else am I missing? Black holes, no definition, no dimensions. Let's see if I can find it here. I don't know. There's another.
A lot of problems with black holes.
Well, the primary one again is we don't know if it's an object or a concept. Until that's decided, we can't continue. We can't even let them use the term because we don't even know what they're talking about. And that's by far the number one. Oh no, the other one was that it's a circular. In other words, what is it made out of? Or as you suggested yesterday, what does it contain? What does it have? Well, it has mass. It's made out of mass. Any way you want to word it, a black hole is all mass, period. And if it's all mass, everybody should say, look, it's made out of mass. It's just pure mass. That's what everybody should say, because that's what a black hole is, just a mass. And so, yeah, when people get asked this question, mathematicians get asked this question, their minds go blank, and they say, well, we have no idea how to answer that question. You should. It's made out of mass. But then the question is, what is mass? And if we look at it in the context of a black hole, it's got to be the quantity of matter. And what's the problem with that? Well, the problem with that is that the black hole crushes all matter out of existence. And if that was the quantity of matter, we crushed the mass out of existence. There is no mass. So we have a circular definition. We have a bunch of mass we call black hole. What is mass? Quantity of matter. Matter gets crushed out of existence, and we're back to, we've got no mass. So it's a circular argument. That was the third one. Anyways, the point is that, black holes, and I'm not sure there's much more criticism that you can bring up against the black hole. It just fails everything. The question Ans asked yesterday, which is kind of interesting, is why are black holes so popular? Why are they so interesting? And that's why I labeled today's intro as Fascinating Black Holes. Now I looked up a couple of videos today to find out, what are people putting out there. And I'll just quickly show this. This is kind of funny because, here's a popular one, 4 million hits at least, right? And this is what they show for a black hole. Okay, they show this evil thing, this hellish place. You got some broken glass there in one shot. Another one shows this turbulence, this tornado, and it shows the singularity.
And seems like they can just show anything.
Well, yeah, if you look, all these are kind of different images, and all it is just special effects. And I think this guy not only got 4 million hits, but he got like, I don't know how many thousand, like 60,000 likes. And I think people like it simply for the special effects. They don't have a slightest clue what they're looking at, what they're staring at. They're saying, oh, a black hole, and they don't realize that a black hole is supposed to be zero-dimensional. It's just got to be a mass. And then you see this rotating thing that completely contradicts the proposal of mathematical physics. And it's like, these people are not talking to the public. These guys are doing math out there, and they do their equations. That's what they do. And then they show someone, or they insinuate that this is what a black hole is. People say, oh, look at a black hole that, the mathematicians have proven to exist. And when you bring this against the mathematicians, they say, well, that's the popular version. That's a popularization. We deal with the math. And so it's like, we talk in circles. You can't criticize anything from mathematical physics on the qualitative basis, on what it means, on what physical significance it has, because these people say, well, our math is correct. That's the answer to that. And when you say, look at what you're showing for a black hole, you're showing a two-dimensional tornado or whatever. They say, that's the popularization. They just dismiss all that as popularizations. So they never have a physical interpretation that you can stick your claws on, because they always dismiss them as popularizations. They only deal with the equations. And they're not going to enter into a discussion based on, qualitative merits or physical interpretation. They don't care about them. And so this is one of the images that I saw today. The other one is, here's another one. Here are the jets, famous jets. And what you'll see here is that, something constantly shown is that the black hole emits this little, what is it, sprinkler out of a fountain, or I'm not sure what that is. It's like a little ray that comes out of the center of a black hole. And the black hole is quite shiny. You would not think that thing is a black hole. It looks like a white hole, completely illuminated. It looks like a flashlight. I don't think it has anything that's black.
Don't they call them white holes?
Well, I'll get into that in a second here, but I'm saying this is the black hole. Okay, that's what they're saying this is. And
do all people say, kind of join the bandwagon of the fact that black holes shoot out things, or are there disagreements with the fact that some people say black holes only gravitate matter towards it, and other people that disagree and say there's actually stuff coming out of black holes? Like, is there a disagreement there, or is it kind of...
I guess you'll find some mathematicians out there that disagree, but they would be considered heretics, because this was proven by Stephen Hawking. He did this. This is his baby. White holes spitting out, matter. That's Steve Hawking's baby, and it kind of gave a job to all astronomers. Because when, like I said at the conference in Mexico, they say, look, we've discovered black holes, and black holes only swallow matter and swallows light. You can't see a black hole. And the guy said, well, what do we point our telescopes out? What do we look for? He says, okay, we got to give these guys something to do. And so they invented white holes, and they say, look, whenever you see something spit out, that's a black hole. And so now they're looking for spitting. Yeah, and here, this is an image of that. Yeah, but this is an image of that notion.
Yeah, but without the spitting, you can already see planets going around nothing. So don't you just point your telescope at the nothing around which they're revolving? Or, for example, the other one, the fact that black holes suck in the matter from stars. Can you just point your telescope at where the matter of a star is being sucked into?
Yeah, but it disappears. It just
the matter doesn't disappear.
Yeah, it's far away. First of all, it's not like we have a perfect, 2 meter vision of this. This is something that's so far away we can barely see. A lot of this is seen through artificial telescopes. Galileo is one of them, and it's flying out in outer space so that we don't have air or anything interfering, and so it has a clear view. It's probably the most powerful thing we've got out there. And, even that can't see that far away. It doesn't have such a good eyesight.
Yeah, but that's besides the point.
My point is, they don't see...
Whether they see the jet coming out.
Yeah.
And so you don't need that to be able to know where to point your telescope.
Well, you see the jet coming out, but then, it's like the sun, look at the sun. And you'll find some of these flares. They flare out and they form these arcs, these big arcs. And it's like it dissolves... it shoots out, dissolves, and then another flare comes out somewhere else. And it's like these flares are constantly popping out of the sun, and then they just disappear into nothingness, because it's like imagine you've got a fire, and you throw paper in there. Well, maybe at first the fire will push that paper, out of its own, action on the paper. It'll push it out, but as soon as the paper carbonizes, you don't see it in the dark night. And so you see it only for a moment when it's burning, and then immediately it turns into, some kind of ash. And you can say the same thing about what's happening out there. Imagine a sun, a star, throwing garbage out there, burning it and throwing it out. Well, maybe the flare comes out for a little while and then it cools or turns into dust. We can't see it from far away. You say, oh, it disappeared into thin air. It disappeared into a black hole. You can say almost anything. God swallowed it. I mean, I don't know.
But I thought they saw, not a black hole, but a star getting its skin sucked off.
They saw, this is what they think is happening. Again,
but have they seen it or not?
Well, they've seen it in the sense that they've seen it from far away, and that's what they think is happening.
But
it's an interpretation of what their eyes are telling them.
Is that a yes or a no? Did they see
there is no yes or no. It's a maybe. It's a maybe because it's an interpretation of what they're seeing. You see something like, the other day I had you missed it because you weren't there, but I had a picture here that showed an hourglass in a picture, a drawing from the 4th century. And someone looked at it and says, well, I think it looks like an hourglass. That's probably the first hourglass. And it looks like an hourglass, but you can't see it very well, so it's an interpretation of what you're seeing. Is that an hourglass? Well, we don't know, but that's what someone interpreted. Yes. And this is something similar. You see something so far away, and you say, well, I guess it's losing matter from its skin. Something is swallowing it because this appears to go out, and then it disappears. Okay. What are you staring at? Well, you have to interpret it. You got to interpret what your eyes are telling you. And I think this is what's happening. But the point is that this lighthouse version here. It's a lighthouse version, right? It's got this beam coming out. It's ridiculous. This is not what they see, by the way.
Obviously not.
Yeah. Yeah, and the other issue here is that again, you don't see anything black in there. It's got nothing related to black. It looks completely white and shiny to me. Unless my eyes are failing me, but I've seen it in black and white in reverse or something. And so from there, what do they come up with? Well, here they come up with falling into a black hole. And here's the astronaut just falling into the black hole. Poor little guy. And he gets stretched. And his head gets cut off. And his casket and everything. he ends up, in Davy Jones' locker, I guess. I don't know where he ends up. But this is what people like to see. These are the special effects, the good images, and people love this. But the problem is mistaking this for science. This is where the danger is. That people look at this and say, "Oh, is this what the scientists have discovered?" No, not scientists. You can't say it's scientists that discovered this kind of thing. And again, you wonder where the line of science ends and where Hollywood begins, because this is more Hollywood than, in fact, 120% Hollywood and nothing involving science. This is all ridiculous if you want to treat it as a real thing. Here's what comes out of the idea of the black hole. On the one side, you have the black hole. In between, you have this funnel, and that's going to be the wormhole. And on the other side, you have the white hole. You go into the black hole, you get spit out by the white hole. That's the idea here. You can see it's black on the right, white on the left. And you enter through the black hole, like we said the other day. You just enter through this zero-dimensional hole, if you can fit in there, if you're skinny enough. And you get sucked through this one-dimensional tunnel, which apparently, you can go in there with your horse, judging by what people show every day. They show this big tunnel, wide tunnel, supposed to be one-dimensional. And this Einstein-Rosen bridge takes you all the way to the white hole that comes out of another universe. And you get spit out. Like we saw yesterday, the ball being spit out of a hole in a different universe. And people believe in this nonsense. They actually think this is real.
Real quick,
yeah.
Where did they come up with the idea of black holes kind of making matter disappear? Whether it goes to another dimension, another time, another space. Where did they get this notion that black holes kind of de-exist things?
It's got to do with gravity, with the equations. It's got to do with the fact that if you put enough mass into something, you create so much gravitational compression towards the center that it just crushes everything. And they say, well, what happens if you crush it a little more? And what if you crush it a little more? And at some point you say, well, no, yeah, but at some point, well, that's why some people end up with a black ball.
Yeah, black ball is fine. But
yeah, but
crushed out of existence. What do you mean crushed out of existence?
Yeah, lengthwise and height disappear.
It gets flatter and flatter and flatter and flatter.
Well, they say no.
Like,
they
zero.
Since the mathematician is not concerned about structure.
But that's not even. That's just common sense.
Like, I know, but there is no common sense.
Like, it doesn't matter how much I push against the table. Like, I'm not making atoms disappear by pushing into it.
You know what Leo Susskind answered to that? Essentially, he says, we had to forget about common sense. We had to create a new common sense.
That's rare sense.
He says they had to create a new kind of common sense.
That's rare sense, and it should be rarer.
And so we have a new kind of common sense now.
And then it gets weirder when they talk. I mean, crushed out of existence is maybe one thing, but then other dimension, other space.
Yeah, when you
time.
put some. Yeah.
So you can just come up with anything at that point. Like what?
And
does,
that's what they do.
What does gravity, crushing atoms together, have to do with sending it to another time period?
And look at what you said earlier. I'll put that together because there's two concepts here. One is that if you enter a black hole, if you're sucked into the black hole, other people say you don't get sucked. It's not a vacuum cleaner. You just fall in. And I don't really see the difference because if you're in the vicinity of a black hole, there's so much gravity you get sucked in anyway. And that's what it does to stars when it sucks the skin off.
You don't get sucked, you get pulled.
Yeah, okay. You get suckered into a black hole. But this is the point. You fall into a black hole, right? They say, and here you'll see it in again, let me put that in there. The guy falls into a black hole. He goes all the way to the center, to the singularity. If you watch what's happening. He gets stretched thin. This is how it's explained. He loses his head, right? And he goes all the way to the singularity, okay? Yeah. And again, matter gets crushed out of existence in the singularity because there's so much compression, so much gravity, that it just destroys structure and just keeps the mass of structure. Okay, mass is only retained here. Okay, that's the idea. Okay, but that's one concept. Then the other concept says it's the mouth. Black hole is the mouth of a black hole, which is the next one here, right?
What?
Is the mouth of a black hole. Yeah, the black hole is a mouth of a wormhole. Sorry, that's what I meant to say. Like this one here, right? So here you see that you have the black hole on one side, the white hole on the other. Okay, so it's the mouth. So the question is, hold it. We seem to have a contradiction. These guys are talking about me going through the black hole, entering the black hole, going through this wormhole and coming out of the other end, out of a white hole. They say we haven't proven it, we haven't found it, but it's conceivable. It's possible. They're even saying it's possible. And we have a problem because I thought the black hole crushed you out of existence at the singularity. Now the singularity is just a stepping stone through a tunnel that takes you to another universe. Well, I thought you were crushed out of existence.
No, it crushed you out of this existence.
Yeah, your soul your soul goes to heaven,
but
I guess, or hell.
That was the discrepancy we kind of listed out yesterday, where there are many things that supposedly happen out of a black hole. Crushed out of existence, sent to another time, sent to another space, sent to another dimension, sent to another galaxy, another universe. So it's like they're just saying, sucks you in and you're not here anymore, whatever that means.
No, and the worst part is the mathematicians are not part of the discussion most of the time. They just stay away and they say, we do equations. We just create theories and give them to you, and then you interpret them any way you want. So Hollywood has a field day with it because they say, we need all the fantasy you can give us. And if it comes out of the math department or the physics department or mathematical physics department in Cambridge, even better. I mean, we love it because now it's official. Yeah. Now we're not lying to them. We're not giving them science fiction. We're giving them science. This is not a This is not a movie. This is a documentary. Let's get it right, And then, okay, next one here, last one, I guess. It shows how the white hole on the other side spits the guy out. So now we're spitting all these astronauts that are going all the way from the black hole to the white hole, and the guy spit out by the white hole. Look at that. Yeah. So the guy's alive. You know, it turns out that he wasn't crushed out of existence on entry. He wasn't crushed out of existence going through the one-dimensional wormhole, and now he's being spit out by a zero-dimensional white hole, and he's still in one piece.
Well, but they say
that's
that
pretty
you
good.
Be in one piece.
Well, I mean, what is this? Obviously, these are all representations that have nothing to do with reality, but they present this, you know, in the guise of science.
Well,
that's the problem.
But for sure, you don't come out one piece.
Well, but see, they're suggesting it just to get people to dream. Oh, how nice it would be if we could travel to the other side. I mean, what is this? To give people hope? I mean, why is it? I mean, if Hollywood comes up with this stuff nonsense, I don't care. But this is presented under science.
Well, I think a lot of science kind of falls into the hope for the future category.
Is that what it is? So it's just
definitely what it is.
False hope.
It's not false hope.
It's not.
It's reaching for hope.
Okay. Reaching.
It's reaching for hope. It's like yeah, there might still be hope there if we kind of, you know, it's like hoping for hope. You know, it's not that they know that they're lying. It's that they think it could be true. So let's dream a little.
Yeah, but science is not made of dreams. Science is made of reality, not of dreams. Hollywood is made of dreams. Okay, the final one here, just a comment that I found out there, and it's nice to read this. It says, all those images of black holes that you've seen through the years are just, in fact, artistic interpretations. We don't have any pictures, they say. This guy says, right? Despite the absence of real pictures, scientists are today more confident than ever that black holes do really exist. You know, you wonder about that. If that's true, it's really, you know, disheartening. In all, about 50 objects so far have been found in our galaxy that behave like black holes. Wormholes are something more rare and more mysterious. They are possible in theory, but we don't have the slightest proof of their existence, as opposed to simple black holes. And I like the ending. But whatever it is to believe in what they are, it is infinitely more interesting than to say that all of this is nonsense and fiction.
More interesting.
Yeah. You say, no, it's saying it's more interesting to wonder what they are than it is to say that all of the, than to reject it or dismiss it as nonsense.
Yeah, but the word choice is very telling. It's more interesting.
No, it is infinitely more interesting than.
Yeah, but more interesting. Yeah, it's more interesting. He's right about that.
Yeah. In other words,
but who cares about interesting?
Right, that's the point. Right,
and it's more interesting if dragons were existing. Who cares?
and this is the issue.
More interesting if we had wizards walking
around. Of course. And this is the point that
very telling.
This answers your question. This is the question. This answers your question yesterday. Yesterday you said, why are they so popular? Why are they so fascinating? Why are people so enthralled with black holes? This answers the question. It says, it's more interesting to ponder, oh, it's so wonderful, so fascinating that they are. It'd be nice to travel through one, to deal with all that nonsense, than to say, well, do they really exist? What is the definition of a black hole? You know, that part they don't care about. Nobody cares about it. Not the scientists, so-called mathematicians, right? Not the people out there, not the masses. Nobody cares about it. Everybody wants the Hollywood version, the flashy effects.
But it's not only flashy effects, it's what that could mean for our future as a species. A lot of science nowadays and technology is
on survival.
How cool would it be, not even survival, just how cool could life be if XYZ? If we had time travel, if we had space travel, if we had AI, you know, a robot that could, you know, do your cooking and like all these fanciful things.
But then there are two problems with that.
And they kind of cut off, I think the biggest argument that they use for these things is, well, you know, if you say it'll be impossible, like time travel is impossible.
We said that in the 19th century.
Yeah, we said that in the 19th century about flight, and here we are flying around. It's like the Wright brothers screwed it up for everyone. Now everyone's got their head in the clouds.
Yeah. It's like, what was his name, the French guy? Jules Verne.
Jules Verne, yeah.
he thought up all this stuff, and people said, "You're crazy, Jules. This is science fiction." And that science fiction today is reality, is technology. It's called technology. And so people have this idea that because Jules Verne said we'll travel to the moon, and he was treated as a nut case, and we did finally travel to the moon, or we built rockets, we built airplanes, then the same thing is true today, that today people say, well, it's impossible to go through a fourth dimension or whatever, and someone will say, well, Jules Verne was, everybody told him that he was crazy too, but today we do fly, in airplanes and go to the moon, and so tomorrow we will be able to go through the fourth dimension. And people have these ideas that, one thing is that Jules Verne was not aware that he was saying something which was within the rules in which the Mother Nature runs her shop. And here we're talking about stuff that is irrational, that's not even imaginable, let alone possible. You can't build technology on something that is irrational, that you cannot even imagine, you cannot even put on the board. Mm-hmm. Otherwise, you can't develop.
One thing you did get right is we still haven't gotten to the center of the Earth, so you did get that one.
Yeah, but we did fly around in balloons. I don't know if around the Earth in 80 days, but...
we do it way faster now.
Yeah, but not in balloons, maybe. Maybe in a Zeppelin. I guess that's a balloon,
I mean, that's old school. That. We don't even use Zeppelins anymore.
Not anymore.
But it goes to that question, which is, who's to say what is impossible, and therefore everything is possible. Time travel, black holes... Whatever you name it, if we can put it in numbers and do an equation with it, it's possible.
Yeah, and this is the danger. The danger is to use math as a language for physics. If you can do it with math, if you can do it with an equation, put some numbers and variables, and even fudge with them a little, if you can get something there that you can convince the other mathematician that you did your math well, that you did it correctly, then people can draw conclusions out of that which are irrational, and you say, well, yeah, but what's that got to do with reality? Assuming your equation is perfect, I don't care, But to say that from there, you're going to draw conclusions about the real world, that's a big step.
But it's not that math is or isn't the language of physics. It's worse. They're using math as the language of hope. It's like,
is that what it is?
We can make the equation work, so it is possible. Hold on to that dream, boys and girls. We can actually make this happen. Like they're trying to get to Mars at all costs, and it's insane.
Elon Musk.
Yeah, Elon Musk among many, and it's like that one you can at least draw on the board, right?
Yeah, that one is possible. Yeah, that I can accept.
But it's so far fetched, and it's like we're just reaching for the craziest things we can still pull off, which is cool and all. But then it kind of gets weird when you talk about things that are just impossible. It's like,
yeah, going through a fourth dimension.
Yeah,
I mean now we're talking about or going through a one-dimensional wormhole, entering through a zero-dimensional singularity. That's irrational.
We don't even know what we're asking.
Yeah, that's completely out of bounds. And to equate that in some way, with science, is where the great danger is.
No, it's like if we had a genie, right? And I asked the genie
in a zero-dimensional bottle.
No. It's just a normal genie, a magical genie.
Okay. And rub the lamp.
My first wish.
I'll rub the lamp.
My first wish is I want humans to be living on Mars comfortably, like they are on Earth.
We can probably do that.
Wiggle his nose and make it happen.
Okay,
if I tell him, hey, show me a zero-dimensional black hole, he's gonna be like, what?
Yeah, what am I supposed to show you?
Even I can't do that one.
Yeah, and that's the point. The point is, some things are irrational. But I've told some people about these things, and they insist that anything is possible. They're convinced that humans can make anything happen. And you say, look, we're talking about four-dimensional and zero-dimensional. Can you get into a zero-dimensional point? Yeah, they believe you can. And you're wondering if you're talking to a what kind of, and some of these people, they look normal. They look normal, and you wonder about their state of mind if they really believe this stuff, and you say, my God, these people really have a serious problem.
But that hope and who's to say what is impossible, those things are blindsiding so many people, and mathematical physicists kind of use that and blindside themselves. I mean, anytime, like, not to throw dirt on him, but whenever I watch Michio Kaku, it's creepy because he has blindsided himself with so many fantastic kind of otherworldly thoughts that he doesn't have his feet on the ground. You know?
Yeah.
And it's just, you can't even listen to him anymore because he's talking about time travel. I mean, even in fiction, time travel doesn't make sense. Even with Harry Potter wand, even then it doesn't make sense.
Yeah.
That tells you everything.
They cannot.
If even in a magical
they have to
world,
cheat. They have to cheat.
But the plot doesn't even make sense. That's what I'm saying.
Oh,
like it literally does never make sense. Even with magic, time travel doesn't make sense. So what makes you think that in the real world it would make sense?
Well, I guess not everybody picks that up from the movies. Maybe some people go to the movies, they don't catch those things that maybe you catch.
That's just because they didn't think about it.
Well, that's my point. My point is they just watch and they drool, you know, and they're watching and say, oh, how interesting. And they don't see the errors, you know, of what they're watching, the logical errors, the rational errors.
Yeah.
And so they look at that and they just swallow that.
You said it right the first time. It's not rational errors. It's really logical errors is what I'm talking about.
Yeah.
Even logically, it does. Like even with magic, assuming we throw rationality
but they don't see them
out the window, the logic doesn't follow if you think about it long enough.
Yeah, the killing your grandfather and you know what is it? Brian Greene jumping into the past, and you got all these Brian Greens every second of the day jumping into the past. There's a million Brian Greens in the morning.
I mean,
what the hell does that mean?
The word paradox is very tightly linked to time paradox because of time travel. Because the word paradox is almost exclusively used for time travel because paradox literally means illogical. Like, not besides irrational. Forget, even if we use magic, it's illogical. It doesn't make sense even with magic.
Yeah, you could have fooled Niels Bohr. He said in the 1920s, right? I think it was the late 1920s. He said, "Oh, what is it? How happy we are," or something like that. He says, "Hey, that's great. We have met with paradox. That means that now we have a chance to make progress."
A chance to make progress?
Yeah, because if you reach paradox, that means there's something you don't understand. That means now you got something to study. Now we can, you know, we can make progress because we reached the wall.
That's actually a really good point for what we constantly ask, which is what do physicists do all day? Is probably make more problems for themselves and other physicists.
Yeah.
They answer a question, and with that answer, they create two questions. And then to answer both of those questions,
you got to give jobs.
4 questions.
You got to give jobs to people.
So with every question they answer, they create more questions, thus ensuring their own job security.
And that of the next generation.
And that of their neighbors too. So it's like this endless questions and answers that gets even wackier and wackier, and we're at no holds barred. So almost any question that you can put down a number is valid, which then makes you think, okay, if that is true, then more questions, and then more questions, and then
it's just crazy. And black hole fits completely within what you just said because you know, black hole does raise more questions than it answers. And again, nobody's paying attention to the real questions involving a black hole because those are things that have to do with science. People are not into science. They don't care about science or physical interpretation or logic, whether it's rational or not. They only care about the flashy effects, as you've seen here, black holes. Why did this guy get more than 4 million views and over 60,000 likes? Because, well, among others, maybe there's some other reason, but I think one of the primary reasons are the flashy effects.
But I think you're looking at the wrong one. It's not flashy effects.
Okay, what is it?
It's hope for the future. It's a big difference. It's what use could we have with this? Like the question I asked you yesterday.
Okay, that's important
What
too.
energy can we harness from a black hole? Like, they're talking about use.
Yeah, and that's true.
I think use comes first. They're saying, okay, we have hope because we can use this later, and then it's like, oh, and it's cool. It looks flashy. It's like, oh.
You know, I use that same argument in a different context, but along the same lines, and that is that the U.S. military, you know, they could have canned NASA a long time ago. They could have gotten rid of a lot of these so-called mathematical physics think tanks. The reason they don't, or that they continue funding all this, is they're expecting some outrageous technology that will help the military gain advantage over the Chinese or over the Russians. And I'm sure the Chinese and the Russians are doing exactly the same.
Everyone's looking for the next atomic bomb.
Yeah, they're looking for a bigger bomb or something that'll give them advantage over the competition. That's what it's all about. And the only reason they maintain all these think tanks is they're convinced that, you know, the bomb is not the last word in military preparedness.
Well, no, I think it's more along the lines of, if there is something that we have yet to discover, it's better that we discover it, not our enemies. So let's put in money just in case it's like a fail-safe. Like, in case there's something
this is my point.
Found
but
out.
This is my point. My point is that a lot of these think tanks and whatever, these mathematical physics out there, they're maintained by all these, the military and the government and so on.
Because everyone thinks there's going to be a use.
Because they all expect or think that, hey, if someone's going to come up with something new, it's going to be these guys. And they came up with a bomb, right? Right? They're the guys who invented the bomb, or discovered the bomb, whatever. Then obviously they can come up with the next big thing.
Well, that's a good question. What is the purpose of science?
Yeah, and
is it to explain or to get some technology?
Right, and that's why I try to separate those two. I was saying technology has nothing to do with science,
nothing. I think that's
nothing. One is explanation, the other one is developing of. If we define them correctly, they have nothing to do with each other. And that's why I always give the example of Iran. Iran knows as much math as everyone in the West. Iran doesn't have the bomb. And you say, well, hold it. These guys know all the math. They know what an atom is. They know how all this energy comes out of an atom if you smash it, etc. Yeah, they know all that stuff. They can do it by heart, just like anyone in the West. But they don't have the bomb. Why? Because the bomb was developed by trial and error, you know, in Alamos, in New Mexico. And they sent a lot of so-called mathematical physicists out there, and they worked on, you know, equations and so on. They did all that. But, you know, the guy who developed it really in the lab by trial and error. They tried one thing, they tried another thing, they tried another one until they got it right. And what the Iranians are still doing, are still trying to figure out, you know, one step at a time, how to build the bomb. They've got the theory. They've got that. They know the numbers. They've got the chemistry all wrapped under their arms, but they don't have the bomb because you develop it by trial and error. Technology has nothing to do with science. They got the science, maybe the explanation, assuming it's correct, but they don't have the bomb. And those are two different things. And
but see, that's where I disagree.
But it's definition.
Yeah.
Start with definition.
I like saying that science and technology are two different things.
Good.
But they do have something to do with each other.
Okay, what do they have to do with each other?
The fact that with technology we have questions to answer in science. I mean, when you have
questions, yeah, you always have. You don't even need technology for that.
You do, because you have to have some effect, some new effect that we haven't found yet, and be like, oh, how does that work?
Yeah.
Like first time we found magnets.
Yeah.
You could say that was technology.
Yeah, but my point is the science part is not looking for questions. The science part is answering them.
Things, but they do have a lot in common. They do have a lot to do with each other. That's what I'm saying. I don't like it when you say they have nothing to do with each other.
I say they have nothing to do because by definition, if you define what each word means, then they have nothing to do with each other.
But they do have something to do with each other. They're just two different things.
Well, by definition, they're two different things.
Two different things, but they do have to do with each other.
Okay, if you want to say it that way, I don't believe that. I don't accept that. I'm saying that by definition, technology is the development of gadgets by trial and error. Period. You don't need to know what a magnetic field is. You don't need to know how gravity, what really is the mechanism of gravity. You don't need to be able to explain any of that. You don't need to know what light is, if it's a wave, if it's a bunch of a flow of particles. You don't need to know any of that in order to use light, develop gadgets, lenses, whatever. You don't need magnetic field to know how a radio works. You just need to know, how it works or what effects it has. In that sense, I'm saying that science has nothing to do with technology.
Is the current purpose of science, not the way you define it, but the way it is used, is the current purpose of science, especially physics, to dish out hope?
Hope. I love that. No, I like your first statement. Math is the language of hope. I like that one. Now we should put that in lights. Math is the language of hope. These guys are giving hope. They're talking about black holes, being able to travel through wormholes to another universe. That is being able to beat the speed of light. You don't beat the speed of light by running against light. No, you do it by taking the shortcut. It's like the turtle and the hare. The hare and the turtle. This guy runs fast, but he kind of was dumb. He fell asleep or whatever, and the turtle just passed him. There's something similar. We're the turtle, and here's light. Light goes at 300,000 kilometers per second. We even give it a head start. We go through the fourth dimension and arrive before light does. And so people like that because they say, I thought it was impossible, but now we found a way of making it possible. And yeah, so in that sense, mathematics is the language of hope. That's a good way of putting it. But what was your question again about hope?
Is the current purpose of science to deliver hope or to create hope? Does it have no other function at this point?
Yeah, but hope gives me the impression that we are all depressed. Is that what hope means in this context? We're so depressed that we need hope?
Why does it have to be depressed?
I don't know. Just putting it in that context. Is that what it is? Everybody's down because there are no jobs out there and life is rough, and what is it then? I mean, if we know that we have...
Life could be cooler, that's it. Life could be better. It's like in the past, people thought of flying. It's not like they couldn't live without flying. It's just, it'd be nice if we could fly.
So in that sense, hope. I thought you were putting in the context of,
Well, it could be hope for new jobs, hope for new cool things that we can see, essentially.
For surviving
Surviving
the mass extinction.
No, just hope for new.
Okay.
Hope for new things.
Yeah,
that's why everyone likes virtual reality and artificial intelligence and going to Mars
and playing games because there they can play something they don't see in real life. They can do things on that screen and see things.
Well, that's a different thing.
But more or less, it's along the same lines. They can simulate on that screen whatever game they have, which is outrageous. They can do things that they can't do in real life, and they say, well, in that sense, you can say is, I can't do it today, but if I can do it on the screen, maybe someday I'll be able to do it out here as well. Why not?
Because we're talking about, because when I'm playing a game, I'm not thinking, I could have some use for this in real life.
Why are games so popular? Isn't it a way of simulating reality?
No.
In a way that you can't in real life?
Okay, but that's a vague way of putting it. Simulating reality in a way that you can't currently, yeah, but that's very vague.
Why is it vague? I'm saying that what I'm suggesting is that
escaping reality. It's like drugs.
Well, in a way it's escaping reality, but in another way it's like, that's nice. Look what I can do on the screen. And then you get this Jules Verne syndrome where you say, well, obviously we can't do it now, but we should be able to do it in the future if I can see it on the screen.
No, because there's games about the Middle Ages, and most games are not about the future. Let's put it that way.
Okay, I'm just talking about those games that are about the future, about technology that we don't have yet, that can do things.
Unrealistic on some sense.
And don't people like those games?
Yeah, but no one's thinking, this will be real in the future.
No, but when that guy leaves the screen and he goes, to McDonald's or whatever, that thought maybe is in the back of his mind. He played with this game all day long, and if someone asks him like me and say, do you have your feet on the ground? The guy's still floating in air. And he'll say, oh yeah, I went through the fourth dimension. You went? Or I can, or in the future we will.
The interesting thing about games is it does get you thinking what ifs. But
right.
And I guess it's a blurry line between what if and could be and then is.
People lose touch with reality.
Yeah,
that's my worry.
Well, in general, we've talked about this before, where everything nowadays is more abstract. So since we deal with so many more abstractions than our ancestors, we're kind of swamped with abstractions, and then we can't.
We're floating in air.
Yeah, we can't tell the difference. Taxes. Getting on the train, what time the train comes, all these abstractions.
It's all abstraction.
We're inundated with
Neanderthal just hunted bears, he just killed something.
So on some level, we're more, abstractly, we're more prone.
Abstract oriented.
But we're better at abstractions, which is helpful in many ways.
Better.
I can use a computer much better than you can.
Well, okay, you're talking about in that sense abstraction, yeah. Obviously, we can use computers better than people in the 19th century.
It has pros and cons, because the pros are we can deal with intangibles, and we can organize ourselves much better than people could in the past. We're more aware of what's possible and what communication does, but at the same time, we don't have our feet not even close to the ground.
Yeah, because I see. It's one of those things I mentioned a couple of weeks ago. The word abstraction, okay, is an antonym of the word physical. In general, I mean, maybe there are different definitions, but you can quickly use physical and abstract as two opposites, right? And when you get away from physical and get more into abstract, you get away from physics. And in fact, you get more closer to mathematics. But mathematics is abstract.
But that's not exactly true.
No, I'm not saying it is exactly. All I'm saying is think about that, because Max Born said, physics today is a little more has become more abstract. And what is he saying? He's saying, look, we're getting away from physics. In a way, he's saying we're approaching more mathematics, which is the abstract. A language, it's abstraction.
I mean,
math is purely abstraction. So we're getting away from physics. It's like these two opposites, we're getting away from physics, approaching mathematics.
Well, but real quick.
But by doing so, also we are floating in air because we're getting away from the earth.
But real quick, a counter argument to that is the fact that you kind of have to abstract to come up with the rope, or when you're talking about huge things like the sun, you can't really touch it and look what it does.
Theoretical physics is abstract in that sense.
It's abstraction dealing with reality,
objects. Yeah. Because if you deal with objects, you have your feet on the ground. It's when you just go to the math, to the equations, and try to only describe, which is what math does because it can't explain, but you derive or infer explanations from those equations, and they come out completely irrational, then you're really floating in air. You're no longer with your feet on the ground. And I think that's exactly what's happening with mathematical physics.
I think
it's gotten slowly away from physics and more like Max Born said, closer to abstractions.
I think if you took someone from the Middle Ages and put them here, you'd think we're all crazy.
Oh yeah, I'm convinced.
Who are you talking to? What are you thinking about?
Yeah.
And
no.
Okay.
On
the table,
but forget about the technology.
No, I'm not talking about the technology. I'm talking about how we interact with the world.
Okay, let's take a guy from the Middle Ages. Let's take a guy from the Middle Ages and a guy from today. If you want to be a participant, fine. We'll put you both on an island. There's no TV, no technology, no anything. Just the two minds. We have the mind of the Middle Ages, of, I don't know, the 4th century, if you will, and you have a guy from the 21st century. They're communicating. We have Old English guy against a New English guy, right? And so they can still communicate more or less. Their ideas, their mental state would be so different that I think the other guy would say, yeah, you are crazy, because we're into all these abstractions that we're familiar with. And he says, I plant seeds in the garden and I grow crops.
I think
his world was much simpler.
I think the outcome would be that the middle-aged guy
would shoot himself.
Would tell the modern guy that he's crazy.
Yeah.
And the modern guy would tell the other guy that he's not looking at the bigger picture. That's exactly how that would go. It's like the guy's like looking for food right now, while the other
you're only looking at the qualitative interpretation. You haven't seen the math.
Real quick, I wanted to ask a question about technology and science. There's a big difference. I mean, I'm pretty sure it's two completely different groups of people. People who develop mathematical, physical theories, and people who develop technology right now, right?
I think it's always been like that to a great extent.
But that's the question. I guess I'm more interested in the people developing technology, because they
more realistic.
Essentially, I mean, by default, they're more realistic because they're actually doing trial and error.
Not a computer programmer.
What?
Computer programmer, he develops software, for example. He's not really doing a technology thing, even
Well,
though
it
it's
kinda
considered.
is.
He kind of is, but it's not the
Because
same
it's
thing
still
as going
tri-
to the lab
well,
and
it's still trial and
working.
error, that's my point.
It is, but my point is that that's a little different. It's like writing a book. Is that technology? Like in the 19th century when Alexander Dumas wrote, the Count of Monte Cristo, was that technology? Can we call that technology? And this is more or less the same thing in the sense that a computer programmer shows you how to do something better, more efficient, maybe in a computer, maybe he works on a program for a bank. Can we call that technology? Well, we factor it under technology. We say, well, he made the software that makes this run more efficiently, and we call that technology.
Why wouldn't that be technology?
Because technology has generally, at least traditionally, been associated first with manufacturing, not with services. That's the first one. The second one is it's when you improve a gadget, you make a TV more efficient, that's fine. But if you make a computer program more efficient, is that the same thing? Maybe you can call it technology, call it whatever you want it. You can give it a name. But the point is that qualitatively, these are two different things. Developing a computer program versus developing a machine. And making it better, more efficient, whatever.
Yes and no, because one is essentially just rearranging how the machine operates, that's programming, while in the other one you're rearranging how is the machine made,
working,
or how does it work at all. One is hardware, one is software. But I'm more interested in the hardware. We can stick with the hardware guys. When they're trying to figure out how to build rockets to go to Mars. Or more simply, when you talk about the Tesla electric cars, they've got their feet on the ground somewhat. Because they're building things, they're making realistic things, but at the same time, it's like they're on the border of because they're essentially kind of breaching new ground, or kind of new ground, or hybridizing old ideas. I don't know how to put it, but they're kind of trying to find out what is possible. So there seems to be this very clear distinction with people who are developing technology, and they're kind of pushing the bounds of what they know now, or kind of putting old ideas together to see if it works. So they're kind of like testing new things with this trial and error, while the other guys have no reference point or have long lost their point of reference of what is actually possible. So they're just kind of juggling ideas up in the air willy-nilly to see what fantastic hope they can scrounge.
That's one angle. The other angle that you should consider in that same logic is that we knew, like in the semiconductor industry, we knew that we were making chips ever more powerful, faster, more powerful and smaller. So they shrunk and became more powerful, shrunk more and became more powerful, or did more.
Who were the people who were actively trying to make it better as opposed to just making it? Or what was the
well, there's an interaction between different kinds of engineering. You have the device engineer, you have the design engineer, you have the process engineer.
So it's just some random guy that says, "Hey, let's try this to see if it
works
better."
To some degree, there's a feedback from what you test in the lab. You test something, you say, well, if we make this smaller, thinner, or out of this other material, then it's going to conduct faster, and so it's going to make the device faster. It's more resistant to heat. You look at all these parameters, right? So and based on that, you say, okay, then why don't we build our next device, this, and this? And you give that to the design guy. The design guy knows, how much current can flow through a bus line. He knows what material he's got to put in there, whether he's going to use aluminum or titanium nitride or polysilicon or whatever. So they're
testing new things as they build things.
And again, they get all this information from testing in the lab. That's why I always say, it's not that the math describes the technology. The technology came first. First, you went to the lab. Then from there, you pull the equations. And then you apply that back in there and say, okay, now we know how fast the current runs in aluminum under these conditions. And based on that, now you build a new device. And that's the cycle of technology. But what I'm saying, what I was trying to get to is that, we knew in the old days, and today it's confirmed, that you cannot continue infinitely, as they say, incessantly, as I say, making the devices half as big, twice as powerful. You can't just continue that indefinitely. At some point, there's a physical limit. Otherwise, you reach the hydrogen atom and say, okay, now I can do it only with a hydrogen atom. That's baloney. You can't. You can't make the chip ever smaller, 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 smaller. Till you get to one atom and say, now I'm going to cut the atom in half, and then I'm going to work with quarks and not with gluons. You can't do that. At some point, there's a limit to the physicality, like of a chip. And in the same way, I think you have a limit in how fast an airplane can run, the maximum speed here on Earth.
It's like saying you can only make a phone so small.
Yeah, and everything is. I think all technology has a limit in that sense. And I know a lot of people don't like me saying that because they say, you mean all technology is will come to an end? Yes.
Oh, yeah, but the weird part about that is, again, back to the who's to say what's impossible, where it's up to the guy who's developing the technology. At what point does he give up? At what point does he say, okay, this is as good as it gets?
Yeah, but then you get the other problem, the other side of that coin, and that's the famous singularity. Singularity in the technology sense, not in the mathematical black hole sense.
Oh, we're talking about artificial intelligence now?
Not in a way, yeah. What it is that a lot of these people out there, they have these ideas that we're going to get to a point called the singularity, where all technology develops to this point in time, from where, listen carefully, from where technology from then on just expands exponentially. In other words, we will be inventing things that we cannot even imagine today.
Yeah, but real quick, the reason they say that is because that
Hope.
Singularity is. Oh yeah, but I'm saying the logical reason they say it is because once we develop into artificial intelligence, it'll be so much smarter than us that from then on everything will be developed.
And that's the point. And the intelligence that we develop will do it for us.
Yeah.
So we can take the rest of the day off. And I don't know how we're going to live, without salaries, without jobs. But that's beside the point. The point here is that they say we're going to reach this point called the singularity, from that point onwards, technology develops exponentially. And again, the question that I pose to these people who believe this nonsense is, it's the other way around. It's like we reach a dead end, and that's the singularity. Death is the singularity, not the birth. And they see it in reverse, but that's just ways of looking at these things.
But it's that hope thing that I think it's like a human nature where
hope.
As soon as you come with...
You cling to life.
Yeah, but if you come with a theory, I mean, almost all of your theories are about killing hope, which is, I think, the biggest factor why it isn't popular.
Yeah.
Because no one wants to listen to that. No one wants to hear...
You're gonna die. You're gonna die.
Time travel is impossible. Thanks, Buzzkill. Who invited this guy?
Yeah, can you go to a fourth dimension? No, you can't.
No, you can't.
We'll cut that route out. I want to escape here. No, you can't do that either.
Can we go to Mars? No, we can't do that. We're done. Everything.
But then it's a false hope, and you can say, well, that's good for politicians. They don't care about that.
But you call it a false hope because
it is a false hope.
Yeah, but that false hope is an opinion.
Yeah, it is an opinion, but it's more than an opinion when you look at this. When you show that something is rationally impossible.
That's besides the point. But
so if it's irrational, you got to say, look, you can't go through a fourth dimension because there is no such thing.
But there's a difference between going through a zero-dimensional black hole or time travel and going to Mars or making really smart technology.
Okay.
They're at least in two different camps. One,
I agree.
One is kind of an amalgamation or a bettering of what we already do.
Yeah.
Like they're talking about having a fridge that orders food for you.
I want one that freezes my beer in 2 seconds. Now that would be great.
Liquid nitrogen. See, those are still kind of feasible. But
yeah.
Then we have time travel or going through zero-dimensional
singularities. Yeah, I don't know.
We don't even know what it looks like or what it does.
I don't even know if I can fit in there. I've got too much of a tummy to fit in there.
Let's harness some energy out of it, whatever that means.
Yeah, but this is that's where you're just 1 inch away from irrationality. People say, "Oh, I got all the way up here. All I got to do is take another step, and I'll be beyond the singularity." No, you'll be in hell,
Yeah,
because
people,
there is no
that's the
such thing.
People
There.
think that all that is on the same gradient.
Yeah,
But they're not. They're two different gradients.
And this is the danger, that people have lost that borderline between reality and not fantasy, irrationality.
Hope will do that. Huh?
Yeah, and
Hope will do that. With hope, you'll believe anything.
Well, I have no hope. So at least for today. So I'll see you tomorrow. And
on that note, hope is dead. Sweet dreams.
I don't want to give you hope, but I think I'll be here tomorrow. Okay, we'll see you tomorrow, same time, same station. We'll see you then. Bye-bye.